So, in today's video, we'll be learning about right triangles. Now, to identify right triangles, identify them, there's always going to be one angle that has 90 degrees. Okay? I'll tell you how to identify which angle that would be in a moment. 90 degrees. Okay? The other two angles doesn't really matter that much as long as one angle is 90 degrees. However, all these angles must add up to 180. So x plus y, this will be x and this can be y, plus 90 have to add up to 180. Okay? So then one side will be called C, the other side will be called A or B, doesn't matter, and then B or A, doesn't matter. However, C matters because C depicts the hypotenuse, and the hypotenuse is the line at which it intersects the two other side lengths, so here and here. And that's how you can identify where the hypotenuse is. Now, to identify the 90 degree angle, it's basically where the side lengths intersect. So the side lengths intersect right here, and they form a 90 degree angle. So that's how you can identify the 90 degree angle. Okay? So now, let's get into solving right triangles. To solve right triangles, you must use the formula a squared plus b squared is equal to c squared. Now, let's say we have the right triangle like this, and then 5, 3, and then this is b. Now, we know that a is 3, so 3 squared. Remember that 5 has to be c since it's the hypotenuse. Okay? And I'm already telling you that this is actually a right triangle, so you don't have to worry about figuring out whether it's a right triangle or not. Let's do that to show that it's a right triangle. Okay? And then b squared is equal to 5 squared. Okay? So then we put b squared is equal to, remember, subtract c squared on both sides, and then we get 25, 5 squared is 25, minus 9, 2 squared is 9. So then b squared is just equal to 25 minus 9, which is just 16, and b is just equal to 4. That's our answer. Meaning that b is equal to 4, so you've solved one side. Now what about the hypotenuse? How do you solve for 5 or something? Or the hypotenuse? Well, you do the same thing. Just plug what you know into the formula. So let's say, for example, if we have this, I'll make a problem in which you have to solve for the hypotenuse in a moment. So let's just say if you had 9, 12, and this, I need to solve for C. Now, how do you solve for C? Well, this may look kind of tedious, but if you just plug it into the equation, it's not too hard. So, c squared, remember, and I'm already telling you that this is a right triangle. Okay, let's put 9 degrees here to make it a right triangle. And put c squared is equal to 12 squared plus 9 squared. Now, c squared is then equal to 12 squared is just 144. 9 squared is just 81. Now, what is 144 plus 81? Well, it is 225. And then, put c squared there. And then, what is the square root of 225? Well, if you do the math, it's just 15. Okay? So, yeah, the hypotenuse length is just 15. Okay. Now we'll get to the special cases of right triangles. Okay. There are two special cases for right triangles, and I'll just do them on the same screen. So one of the special cases is, one moment, okay, is (45-90) and 30-60-90 triangles. Let me put the degree sign in each of them. So for 45-90, basically, the two side lengths, right, will make a 9-degree angle. So this is 9 degrees. Then this length here will be 45 degrees, and this length here will be 45 degrees. Okay? For 30-60-90 triangles, okay, this length here will be 30 degrees, and this length here will be 60 degrees. And then this length here would just be 90 degrees. So I'll just draw the same triangle here. Remember, it's still the same angles. For this triangle here, basically, the two side lengths will be x, right? And this is for the side lengths of a 40-90 triangle, 45-90 triangle. And then the hypotenuse will be x times, right, the side length times √2. But for 30-60-90 triangles, will be x, right? And x is the shortest side. And then x times the square root of 3, and then 2 times x for the hypotenuse. So 30-60-90 triangles are their lengths are hard to identify, but the shortest side will always be x, and then the second shortest will be x times the square root of 3, and then the hypotenuse, remember, if you can just identify the hypotenuse and the shortest side, your life would be easier. And then the hypotenuse will just be 2 times x. So now we'll do an example of each. Let's just say we had a triangle like this. So, and it's just 2 here and 2 here. What is C? We'll call it C for now. And I'm already telling you it's a 45-90 triangle. So since it's a 45-90 triangle, right? Pause the video and just try to solve it by yourself for C. Okay, to solve for C, it's just this, right? It's just 2 times √2, and that's your answer. So it's very, very easy, if you know all these tricks here, to solve for the hypotenuse or whatever length you want. Now, okay, this will be trickier, okay? So this one will be trickier. So I'm already going to tell you that this side right here is going to be the shortest side. The shortest side, remember that. Okay? And you have to solve for the shortest side. Okay, and this side here will be 6, and this side here will be, we'll just do 3 times √3, okay? All these sides are mathematically correct, okay? And now, solve for x, or the shortest side. And this is also a 30-60-90 triangle, so you can apply the rules. So try to solve for x. How'd you do it? Well, we know that 6, right? We can rewrite 6. This is also just equal to 2x. Okay? And if it's equal to 2 times x, we can just isolate x by itself to see what x is equal to. So, 2 times x is 6, as I said earlier. Divide both sides by 2, and you get x is equal to 3. So our answer is x is equal to 3. Okay? So yeah, that concludes the video, and you learned about right triangles. See you in the next video.